Okay, this is conditional probability. This is continued, but this is using trees to help us solve, because sometimes our conditional probabilities don't always fit in a table, and we have to use trees to help us solve conditional probabilities. So, our first conditional probability, we're playing a game of cards where the winner is determined by drawing 2 cards of the same suit. What's the probability of drawing clubs on the second draw if the first card drawn is a club? So, first of all, what we're going to do is we're going to set up, we're going to start by figuring out the probability if we draw a club, which we know is, we're going to set it up as 13 over 52, which we know we can do 1/4, but in this case, it's actually going to help us to do the full fraction, 13 out of 52. Now, from there, our second draw, we can draw another club, we can draw a spade, we can draw a heart, or we can draw a diamond. Okay? So these are all the possibilities of things that can happen. Now, we only win if we draw like a club and a club. Okay? Because that's what we're talking about, is a club and a club. Now, if we draw a club on the first draw, there's 1 less club in the deck. So there's 12 clubs now, and there's only 51 cards in the deck. Okay? The second thing, or another thing that could happen, is we could draw a club and a spade. Now, there's 13 spades in the deck, but there's still only 51 cards in the deck. Same thing with a heart and a diamond. There's 13 hearts in the deck, but there's still only 51 cards. Same thing with diamonds. There's 13 diamonds and there's 51 cards. Okay? So these are the things that could happen. Now, what we're going to do is we're going to calculate each of these probabilities by multiplying these fractions. And we're going to use decimals for these. And we want to know this by like getting a club and a club and a spade, a club and a heart, and a club and a diamond. We need to know what these probabilities are. And the process for all these types of problems is going to be exactly the same. So the first one's going to seem a little bit tricky, but then once you get the process down, it's going to be the same steps every single time. So you're going to do 13 over 52 times 12 over 51. And you don't have to write this out every time, but what I'm calculating is I'm doing 13 over 52 times 12 over 51. So this is all I'm calculating to get this decimal. So this is going to be 0.059. I'm going to do the same thing here. I'm just multiplying these fractions. This one's going to be 0.06. This one's also going to be 0.06. And this one's also going to be 0.06. Okay, so now what we have to consider is the possibility of getting, so like the first card drawn is a club. Well, how many ways can the first card drawn as a club? Well, it can be a club and a club and a spade, a club and a heart, and a club and a diamond. So there's 4 ways to get a club on the first draw. And we have to add up those probabilities. So a club on the first draw can happen those 4 ways. And we want to add up all those probabilities. So we would do 0.059 plus 0.06 plus 0.06 plus 0.06. And that's going to equal, that is going to equal 0.239. Okay? So we need to keep that number in mind for right now. The second thing we need to calculate is the probability of drawing a club and a club, which we did on our first, that was our first thing here. It was like our first sequence. The club followed by the club. And so that probability was 0.059. So then our final thing that we do is we take 0.059 and divide it by 0.239. And that's going to give us 0.239. 0.25, which would be, we change that to a percent, it would be 25%, which is a higher probability. So this up here is about, just knowing we get a club in a club is about 6%. But if we know the first card is a club, that increases it, we go from 6% now to 25%. It's still a low percent, but knowing now 25% is higher than 6%. So this right here is actually our final answer. I just kind of circled the ones before so you would know what numbers we're using, because this number went here and this number went here. Okay, so looking at our second one, it's going to be done the exact same way, okay? A bag contains 6 blue marbles and 2 brown marbles. 1 marble is drawn randomly and discarded. A second marble is drawn. Find the probability the second marble is brown given the first marble was blue. Okay, so here's what can happen. We get a blue marble. The probability that it's blue is 6 out of 10. All right, so after you draw the blue marble, then you can draw another blue one, or you can draw a brown one. So if you draw a blue one, now there's only, so if you drew a blue one the first time, there's only 5 left, and there's only 9 marbles left. All right, if you drew a blue one the first time, all of your brown ones are left, so there's 2 brown ones, but there's still only 9 total marbles left. All right, if I calculate my probabilities, I'm just multiplying my fractions. I'm just doing 6 over 10 times 5 over 9. So 6 over 10 times 5 over 9 is going to be 0.33. All right, if I do 6 over 10 times 2 over 9, I get 0.13. All right, I'm going to go ahead and calculate if I drew a brown marble the first draw, which would be 2 out of 10, because I'll need this for my second problem, actually. So if I draw brown first, then I could draw a blue, or I could draw a brown on my second draw. So if I drew a blue, I have all of my blue left, but I only have 9 total. If I drew a brown, I would only have 1 out of 9. So if I calculate these probabilities, if I drew a brown and then a blue, that would be 0.13. If I drew a brown and a brown, that would be 0.02. So here are all my possibilities of drawing marbles. Okay, so find the probability the second marble is brown given the first marble was blue. So if I get blue on first draw. Okay, so what I'm looking at is blue on the first draw. So right here is I'm looking at these two. So this is what happened on blue on the first draw. So those were the 2 possibilities that happened. So I'm going to add up 0.33 plus 0.13 because I could get blue and brown or blue and blue. So I add up those 2 probabilities. So that gives me 0.46 because those were the ways that happened with the blue on the first draw. Okay, now the order that it happened was blue and brown. Blue, then brown. So I followed the path of blue and brown. So that probability was 0.13. So now I divide 0.13 divided by 0.46, which is 0.28. So it's a 28% chance. Okay, so then the second part of this question, find the probability the second marble is blue given the first marble was brown. Okay, so brown on first draw happened these 2 ways. Okay, so this was brown on the first draw, so I would do 0.13 plus 0.02. So that was going to be 0.15. All right, so then the order this happened would be brown, then blue. So brown, then blue is 0.13. So now I'm doing 0.13 divided by 0.15, which gives me 0.87. And if I change that to a percent, it's 87%. Okay, now this one kind of goes back to yesterday, so we'll do a quick review on yesterday's stuff. In Mr. Robinson's homeroom, 70% of the students have brown hair, 25% have brown eyes, and 5% have both brown hair and brown eyes. A student is excused to go early to a doctor's appointment. Given the student has brown hair, what's the probability the student also has brown eyes? So I'm going to make a table for this. So we have brown hair, we have other color hair, and then we have our total. So then we have brown eyes, we have other color eyes, and we have total. Okay, so it says 70% have brown hair. So 70% goes right here. 25% have brown eyes. And 5% have both. You don't even have to fill in the rest of the numbers because it just says, given the student has brown hair, given the student has brown hair, which means this is your number that goes on the bottom. So we're going to put 0.7. I'm changing that to a decimal. What's the probability the student also has brown eyes? So you take that number, 0.05. Remember, move your decimal 2 places. That's your number that goes on top. And when you divide those, you get 0.07, which is 7%. Okay. And then back to making a tree. Suppose Juan can get to school 2 ways. He can ride the bus or ride with his friend. When he chose to ride the bus, he arrives at school on time 98% of the time. When he chooses to ride with his friend, he arrives on time 95% of the time. He rides with his friend 80% of the time. What's the probability Juan chose to ride with his friend given he arrived on time? Okay, so here's how we're going to set up our tree. So first of all, he can either choose the bus or he can choose his friend. Now, it says he rides with his friend 80% of the time. So we're going to say 0.8. Now, if he chooses his friend 80% of the time, that means, so our percentages always have to add up to 100. That means he would choose the bus 20% of the time. Now, once he does this, he is either on time or he's late for both. So he's on time or he's late. Okay, so when he chooses to ride the bus, he arrives on time 98% of the time, which means he would be late 2% of the time. So we fill in those numbers there. Okay, so then it says when he chooses to ride with his friend, he arrives on time 95% of the time, which means he would be late 5% of the time. Okay, so we've got all these numbers filled in now. Now it's time to calculate our probabilities. So you just multiply. So to get this probability, we do 0.2 times 0.98, which is 0.196. Then we do 0.2 times 0.02, which is 0.004. Then we do 0.8 times 0.95, which is 0.76. then 0.8 times 0.05, which is 0.04. Okay, so now let's figure out what we're going to be adding up. What's the probability one chose to ride with his friend given he arrived on time? So here's he arrived on time, here's he arrived on time. So on time means we add up 0.196 plus 0.76, and we get 0.956, okay? So then, on time, and he rode with his friend. So on time and he rode with his friend, so that would be friend and on time. Right there is that pathway. So that is 0.76. So we do 0.76 divided by 0.956. So that's going to be 0.79 or 79. There's a 79% chance for that one. And that is it.